Hey guys, in this video I'll be showing you how to test your Solidity smart contracts using Truffle. So in the last video we made an NFT marketplace. Having watched that video isn't a requirement for this, but if you are looking for an intro to Solidity and smart contract development, I highly recommend you go and watch that. But otherwise you can still follow along with this, and I'll show you some practices when it comes to unit testing your smart contracts. Anyway, let's get into it. So here we have our market contract that we wrote in the last video. You might have your own contract and that's perfectly fine, but in this case we're going to start by testing this very function. We'll be testing for different scenarios and we'll be testing each of these things individually just to make sure that each little thing works as expected. Now I can see here, like I have tested this function manually before and I know that it's working. So why do I need a test for it? Okay, so one of the reasons is I can maybe down the line I want to make a small change. Sometimes a change might look small, but it could end up just breaking everything. So if we have unit tests for this function, they will make sure that everything is still working as expected and make sure that we haven't overlooked something. So let's begin by going into our test directory and creating a new file called market.js. The name is the same as the contract and it's a JavaScript file. Now these tests will be written in JavaScript. Truffle does allow you to write them in Solidity, but I've seen that most people prefer JavaScript, including myself, so that's what we'll be doing for this video. So we're going to begin by saying const market. We're going to use artifacts.require. We're going to import the contract. We're going to go here and we're going to start this with contract, and in here the name of the contract, which is market, then normal arrow function. In here we'll first declare our variable for our contract instance. We're just going to call it market, and now describe. This is going to be the function here. List token, you can either use the name of the function or just call it list token. I mean, this is all for you. There are some standards and practices that you can decide to follow, but whatever works for you. Here we're going to test different scenarios. So we do have, let's split this into this. Okay, so we have list token, but to list a token we need a token contract and a minted token. So let's also have a token contract. Here we're going to use something called a hook, and that's going to be a before hook, just before like this, and this will execute before any of these describes. We'll have multiple describes after this, so this will be executed before any of them start. Here we'll go market equals market, which is this name over here, dot deployed. This will get the deployed instance of the market contract and assign it to this variable. We're also going to use await because deployed is a promise, and of course here we'll need an async. Now we also need a token contract. In this case it's called NFT here as well, and token equals await NFT, same as here, and then deployed. Now in this function here, in this describe, we can have the different test cases, so we can specify those using it. In here we can say what it should do. So it should, so first we're going to try to transfer list a token without having given approval to our market contract to transfer those tokens. So if you're familiar with NFTs and the ERC 721 standard, you'll know that you'll need to approve. An owner of a token needs to approve another contract or wallet to transfer a token on his behalf. If I have a token, I need to give permission to the market contract to move my token around. If we just try to list the token, our contract is going to try to transfer that to itself, but it should fail because we haven't yet given it permission. So we're gonna test that first. It should prevent listing contract not approved. Now we can go inside here actually and mint the token. We can have await token dot mint. That's this function over here. This doesn't take any arguments, and so we're not going to pass anything, and the expected ID should be 1. So it's currently at 0, but it increases it to 1 before it's actually minted. We've minted the token and we can now try listing it. So here we can go market dot list token, and this takes in this has 3 parameters, which is token, token ID, and price. First one is an address, and it's the address of our contract, so token dot address. Second will be token ID, which as I said should be 1, and we're just gonna put that here, token ID equals 1, and then the price, const price equals, let's say 1000. You can put that to whatever you want. Now we want to make sure that this fails because we haven't yet approved the transfer. So how do we test for a function call to fail? we're going to use a library by OpenZeppelin. We're going to open our terminal and say npm install and for development only, and OpenZeppelin test-helpers. Once that's done, we can go here, const and require from OpenZeppelin test helpers, and we go expect revert, and we're going to use that to test this expect revert, and we're going to pass this function call as an argument to this function, and the second argument will be the actual error that we expect. And in this case we know what that is because we're using this ERC721 by OpenZeppelin, and we can go check what the actual error message is. So we're going to open up the contract on GitHub and scroll down to transfer from. So this is the error message that we're expecting. Transfer call is not owner nor approved. We're going to copy this, go back to our code, paste it here. Now let's open up our terminal, and first we need to run Ganache. So Ganache CLI. Once that's running, let's split the terminal or open up a new one, and then npx truffle test. Now this will take our contracts here, compile them, deploy them to Ganache, and then it's going to run all these tests. Well, just this one test, and it says passing. And yes, that's exactly what we expected. This is the error that we got, and the reason for that is because the market contract is trying to transfer the token, but it's not approved. So first we're going to approve the market contract. So let's just copy this, and this is a test case that will make sure that the listing is actually executed. So should execute listing, and for that to happen we need to set the approval. So token approve, this function is, we can look for it here. Okay, it's this one, approve to is the first argument that we need to pass, and second is token ID. So we're approving market, so we're going to take the contract market contract's address, and the second is token ID, so we're going to just pass that next, token ID. Now we're going to await for this, and this should be async. And now we'll try to list the token again. So go here, paste it, and we're gonna store the result in this constant called tx. It's going to be tx receipt or just receipt, but I just prefer calling it tx. It's fine, it's up to you. If we log this console log tx, you'll see a lot of information. We're gonna see all this. I mean, it's some nice information, but we don't really need it. We're gonna use another function provided by the test helpers, and that's expect event. This is going to listen to any events emitted by our function call, and if we go back to our contract, listed is one of the events that's emitted, and we're going to just check that that is actually the case when we call it in here. So we're going to say expect event. The first argument is the tx, this is the receipt, and second is the name, which is listed. Let's run this again. And there we go. So we get, this is also a success. I mean, it was before as well, but that's because we weren't testing for anything, we weren't asserting anything. And we can also make sure that these values are also the ones that we expect. So the listing ID, the seller, the token contract, the token ID, and the price. And we can just pass these in here. The first one is, let's split this again. So the first one is listing ID, which is going to be 1. Let's just put it here again, listing ID equals 1. Now the next is seller, and we get that from accounts, which is a list of wallet addresses that Truffle injects, and these are the same addresses found here, and each of them has 100 ether. So our first contract, the actual deploying contract, is accounts, is the first one, so it's accounts 0, and that's also the one executing these transactions. Let's just explicitly declare who is the seller and the minter. So let's say minter is accounts 0, or let's make it 1. So mint, and then in here we're gonna say from minter. Mint, as I've shown you earlier, doesn't accept any arguments, but we can always pass in this object. From is one of the properties, and we can also have value and a few others. So from is basically, as you can imagine, just the wallet address that executes that transaction. We can do the same over here. So list token, the last argument we can make it the object from minter. So in the event that's emitted, seller should be the minter. And then we have the token. Token is token.address. Token ID is token ID here, which is this one actually, token ID. And then the last one is the price, which should be the same as this one here. Let's try running this again, just to make sure everything is as expected. And we get an error, caller not approved, and that's because we haven't passed from here. So the person approving this also has to be the minter. And let's try running this again. Okay, now we get another error. So expected one to be an instance of a BN, which is big number or string. So the thing is, here we're passing in these values. So we have token ID, which is an integer, this is an integer, this is an integer. We pass them here to list the token, and that's fine. But the ones that we get back are actually big numbers, which is sort of a wrapper that's used to deal with huge numbers. So we can just make sure that these are also big numbers. So new BN, we can also use BN from Open Zeppelin test helpers. So here we go, new BN, again, new BN, same here. Now all of these are big numbers. Everything here remains the same, and also down here actually. So everything remains the same. We just turn these into big numbers rather than just normal integers. Let's try running the tests again. And there we go, it's passing finally. So one extra thing that we can make sure is that when this listing is complete, the final owner of this token is the contract itself. So in here, after the event, we can check token.owner of, and we pass in the token ID. Now this will execute, this will call the function owner of, which is right here. 1 second. Come on. So here we go. So it takes in the token ID and it returns the address of the owner of that token. So back here, we can store this into const. Actually, we can just, well, this is a promise, so I think this is cleaner. So owner, and we just assert. This is just a function that you don't have to worry about because Truffle takes care of this. And in here, we assert that the actual value, so owner, is the same as the one that we expect, which is market.address. And also make sure to return this because it's a promise, and otherwise it's not going to be awaited for. So let's run this again. And it's a success. And just to prove to you that it's actually working, let's change this to empty, for example. And as you can see, it fails. So let's change this back to owner, and everything is working as you expect it to. So now we've tested this function. You could maybe add a few more test cases, but so far I think this is enough. It's a pretty simple function, so I don't think there's much more to add. And we can just move on to the next one. You could test get listing just to make sure that what you list is the same as what's returned by get listing. That could be a good idea to do, but I'm just gonna skip that for now. I'll let you play with that, and I'm just gonna move on to buy token. So here, actually, we're gonna do another describe, call it by listing. And the first thing we're gonna do is it should. Using should at the beginning is just a convention I've seen, but it's not necessary. You can call it whatever, but I'm just gonna use it. So it should. First, we're gonna test these, make sure that the seller can't buy his own token, make sure that the listing is actually active at the time of the sale, and also make sure that the ether that the buyer passes to the function is equal to or greater than the actual listing price. Okay, so first we're gonna say it should prevent sale, and the reason is seller cannot be buyer. So we're gonna go here, and now we're gonna try to buy listing with ID 1. So we're gonna expect a revert. We're gonna enclose everything inside this, and we're gonna say market.buy token, which is the name of the function. Maybe I should call this buy token. I don't know. So market by token, and it takes the listing ID in. So we pass the listing ID, and we're also going to pass the from. First we're going to test this. So we're going to make the buyer also the seller, so the minter, yeah, and the expected error message should be seller cannot be buyer. And again, we're going to return this because it's a promise. Let's run. And there we go, this listing fails, which is exactly what we want. Okay, so now let's move on to the next one, which is listing is not active. Actually, we're going to do this last. We're going to test for this once the listing has been sold, so it's not active anymore. That way we don't have to recreate the listing. Instead, next we're going to test for this. Make sure that the price is enough. So it should prevent sale again, insufficient payment. We're going to copy this, and in here we're also going to pass in the value. This is a payable function, so we can pass it ether. We're checking for the MSG value over here, and that same value we can pass here in our test. So for the buyer to execute this sale, he needs to pass in at least 1,000, which is this price over here that we used for the listing. But let's say we pass in just 1, and the error message we expect is this one here, insufficient payment. And we need to change this. It can't be the minter anymore, because then we'll get the same error message here. And we also need the buyer, so we're going to do const buyer equals accounts, and then 2. There's 10 of these accounts that are injected, so we have quite a few to play with. Now in here we're going to pass from buyer, and by the way, they all have 100 ether, so don't worry about the value here. Let's run this, and there we go, as expected. Let's just make sure that this is actually working as intended. So if we pass in 1,000, the sale should execute, which is not what we want right now. And there we go. The test case fails, meaning that the sale has not been prevented. It has executed. And as you can see here, there is no revert. Therefore, it has executed. So let's just change this back to 1. And now we test for the sale being executed successfully. Should execute sale. We're going to copy this, const tx equals await market by token from value. We're going to put that as price, and now we're making sure that this event over here is emitted, so the sale event is emitted. So expect event, the receipt, which is tx, and then the name of the event, sale, and then we're going to assert the values. So the first should be listing ID, so listing ID is 1, as we've specified over here. The MSG sender in this case is the buyer. If you go to sale here, so buyer is buyer, token is token.address, token ID, and then price. Let's run this. I forgot to add async over here. Let's just add that, and passing. And just to make sure that this is actually working, let's change this to 2, but we need big number 2. So new bn2. Let's run this. And there we go. So we expected 2, but we got 1, which is actually what we really want. So keep it as is. And then one last check we can do is again this one here. But in this case, make sure that the owner is the buyer, not the market contract anymore. And there we go, it's all working as expected. And now finally we can test this listing is not active. So it should prevent sale, listing is not active. Now this is, we're just going to copy this one here because it's going to be very similar. Except the error message is going to be listing is not active. And the value we pass in the actual price. Let's run this. And there we go. So this test case over here actually executes the sale. So now the listing is marked as sold right here, and therefore the sale can't be executed again. Now let's finally go to our cancel function. So let's do another describe cancel listing. In here we'll have an it should prevent. We're going to test the prevent ones first. It should prevent only the seller can cancel this listing. So we're going to use another address to cancel it and make sure that it doesn't. So it should prevent cancellation. Only seller can cancel. Return expect revert. Inside it will be market cancel. We're gonna pass in the listing ID, which is listing ID. Okay, so the problem here is that the listing is not active anymore because it's been sold over here. We can add a before hook over here, and inside, because we don't want to make these test cases too confusing, we want to keep them simple. So rather than relying on the actions performed by these previous tests, let's just redeploy market contract and the token contract. Let's just copy this first. We can go here into our before. Let's make this async, and instead of deployed, we're gonna do new. So the market contract will be redeployed and assigned to market, and the same thing for token. Then we can mint. We'll use the same minter. We also need to list the token again. But to do that, we first need to approve the market contract like we did before, and then list. We don't need to check for the events and whether they've executed because we're already doing it here. You can, it's nice if you want to, but it's not strictly necessary. Once that's listed, we can execute this and it should fail. The error message we're expecting is this one. PX Truffle test. And it passes, it goes exactly as we want. And here we can be super specific and pass in the from, and this will be not from the minter, so anyone else other than the minter, we can do buyer, for example. Now this before hook is executed before these test cases inside of this describe. Likewise, this before is executed before any of the describes. To make things simpler with tests, you don't want to complicate the logic. You want to avoid any logic at all, actually. So rather than having this global before, how about we make it so that each describe has their own instance of the contract? We can move this before inside the list token describe, and let's make this new. Same here, and then in here, buy token, we can use these ones. And we can do this because here we also require that the token is already minted, approved, and the listing already exists. Let's try running everything just to make sure everything's still working. Okay, awesome. Now let's move on to the next test case for cancelling, and that is listing is not active. Now before we do that, how about we actually cancel the listing, and once it is cancelled, we check for this. So let's do a test that actually cancels the listing. So should execute cancellation market.cancel. We're gonna pass in the listing ID, and we're gonna store the result in TX. Also, it's a promise, so we await and have async here, and this needs to be from the seller, which is also the minter. Now that should, then we use expect event, pass in the receipt, and this is the event that's emitted. So cancel, and then the values are listing ID and seller. So the listing ID needs to be listing ID, which is 1, and the seller is minter. It passes, so let's move on to the last one. It should prevent cancellation again, but in this case it's because the listing is not active. So we do this, just copy this from minter, and the error message we expect is this one. Run. And there we go, it's all working as expected. Now, one little thing you might want to do again is just to test this transfer from. I don't think it's necessary. Now, there are still several things that you could improve. For example, you could add a few unit tests for get listing. But now you know what to do, so just play around. I think that helps a lot, just playing around. And also, as I mentioned in my last video, once these contracts are deployed, they can't be changed. So if you make a mistake or there's a vulnerability, and if your app has become quite popular by the time you find this out, it could end up being quite expensive for you and your community. So make sure that you test this out properly before people start using it. Try to study as many popular contracts as possible, learn about some of the common attacks, and try to just make sure those aren't a problem. Anyway, thank you for watching, and I'll be making more videos about blockchain development, Web3, and stuff like that. So just consider subscribing.